Hello, I'm Jared Skeens, and welcome to the Zoom room. Today, we want to look at our Pure Maths 1 Quadratics unit, Part 6, Inequalities. So what do we do when we run into a quadratic inequality? Well, we've already looked at solving quadratic equations. We've looked at factoring, we've looked at completing the square, we've looked at the quadratic formula and the magic potion, and we've also applied those or looked at those with relationship to sketching. What I want to do now is just a brief session on quadratic inequalities. It can occur as a separate question in the Cambridge quadratics question type, but sometimes you're going to run into quadratic inequalities as you're trying to solve another question type, or it could be a quadratics unit or another unit, and you run into quadratic inequalities. So this is really going to be a brief session, but it's very important what to do when you're running into these inequalities and how you can make sure that you arrive at the correct form of the answer. So it's really the ending of this that's going to be the most important, but also it gives us a chance to review factoring. In these quadratic inequality types, I observe that Cambridge curriculum tends to give you rational answers when it comes to quadratic inequalities. So I'm not saying that you can't get an irrational answer, but when it comes to the inequalities, Cambridge seems pretty consistent at giving rational solutions, meaning you can factor it. So you don't have to complete the square, or you don't have to use the quadratic formula or the magic potion method. You can or should be able to factor these. You should look for that first. Now, sometimes these questions are a follow-up to a complete the square question. So if you've already done completing the square before this step, then you can use the result of your completing the square and you can solve the inequality a little different way. But what I want to show you is how to do it with factoring, because this is going to be the primary go-to way that you're going to want to deal with this, not just when it's one of those little question types by itself, but when it's buried within a process that you're working on. And as you're working through the question, you end up with this quadratic inequality. What do you do with it? So before we get started here, let's look at what is an inequality. And maybe you don't know what this is called, but this is called the trichotomy axiom. Axiom is a self-evident truth. Trichotomy means to cut into three parts. So trichotomy, there's three self-evident statements here. When you're comparing two values, either A is greater than B, A is equal to B, or A is less than B. Should make sense. Notice the inequalities I have put in red the equal sign underneath. In other words, your inequality might or might not have the equal sign. Make sure your answer at the end either doesn't include the equal if you're starting with an inequality like this, or if your inequality has the equal, then make sure your final answer has the equal. So follow whatever the original has. I notice students sometimes lose track as to whether you should or should not have that equal component to the inequality. So just follow the original quadratic inequality. Okay, so the next thing that you should be aware of is in these question types, whether it's a question type by itself or whether it's a bigger question that you end up using this quadratic inequality within the question, usually towards the end as you're getting to the answer, you're going to see this phrase, find the set of values. It's important to read the Cambridge questions carefully because they do give you a hint as to the nature of your answer. If it just says find the value, well, it's singular, one value. If it says find the values plural, where you're probably looking for two or maybe more, but a definite set of, or I shouldn't say set, a definite fixed number of answers, whether it's 2, 3, or 4. Okay. Now, if it says set of values, this set is your key word that you're going to be dealing with an inequality. So again, whether this is a question type by itself or whether it's buried within another question type, you will see in the instructions, find the set of values. That is your clue that you're going to be dealing with an inequality, and usually it's going to come off of a quadratic type equation. Okay, so here's our quadratic equation. Now, your first instinct might be to factor. Remember that the purpose of factoring is to get to the zero product rule. And you can only use the zero product rule if you have a 0 on the right-hand side. We don't. That means we need to move this over to the other side first. Don't try to factor if you don't have a 0 on the right. Okay, so we want a zero product opportunity, and we can't get that unless we have the 0. So we're going to subtract 9 from both sides, and that gives us x squared plus 6x minus 7 greater than 0. Now, remember with your inequality, if you are adding or subtracting to both sides, no problem. If you are multiplying or dividing both sides by a positive, that's no problem. But if somewhere in your equation you have a multiply or a divide by a negative, it will flip your inequality. So don't forget, there's only one extra rule for inequality, solving inequalities compared to solving normal equations, and that is your inequality can flip directions when you multiply or divide by a negative. So don't forget that important extra rule that we don't have with normal equations. Okay, now we didn't multiply or divide, we only subtracted, so our inequality stays the same direction. Now we factor, okay? 99%, most if not all, of your quadratic inequalities will be able to factor, so look for that. So here we have factors of 7, 1, and 7 that subtract to give us 6. So we want 7 minus 1. So that's going to give us x minus 1, x plus 7 is greater than 0. Now, here we are at our zero product rule, but this is not an equals 0. But we're going to use the equal 0 and the zero product rule to define for us our boundaries. So what do you mean by that? Well, if you look at a number line, here's a number line, here is 0. To the right of the 0, we have the positives. At 0, well, it's 0, neither positive nor negative. And to the left of the 0, we have the negatives. So 0 becomes the boundary line between our positives and negatives. When you're working with a quadratic inequality, what you want to ask yourself is, what does greater than 0 mean? It means that our solution set is what causes this expression to be positive, greater than 0. So we're looking for a positive outcome as opposed to a negative outcome within the solution set. It doesn't necessarily mean that your answers are positive or negative. It means when you plug the answers into our expression, the outcome is positive or negative depending on the direction of your inequality. So this is what we're looking for. We're looking for the solution set that causes this product to end up being a positive value. But to determine where our positives and our negatives are, we need to first of all define the boundary. So we're going to look for the zeros first. So when we use our zero product rule, we get x minus 1 equals 0, x plus 7 equals 0, and so we get x equals 1 and x equals negative 7. These are not our solutions. They are the boundaries between where positives and negative sets are located. So what we want to do is we want to create our own number line, and we want to establish our boundaries at where the zeros are at. And the zeros are located at 1 and negative 7. Well, a number line is ordered. So make sure you put the smallest one on the left. Negative 7 is on the left side, the smaller side. 1 is the larger number. Here, you don't have to put 0 in. These are the zeros. What's caused when you plug in a 1 here, that causes you to get 0 when you plug in a negative 7 here. So these are actually our zeros, or our boundaries between the positive and negative sections of our answer set. Now we need to determine which section is positive and which section is negative. Well, we're going to connect this back to our graphs. We just looked in part 5 about sketching. And we've also looked, the very first form of sketching that we looked at was the intercept form. So when we are in intercept form, it means, again, that these are the roots of our graph. Okay? Means it's where our graph crosses the x-axis. And if you are looking at it from the perspective of it being an x-axis, if your graph is going through that root and your graph goes above the x-axis, well, that's the positive section because your y value is positive. And if you're below the x-axis, well, your y value is going down. That's the negative section. So we're going to take this and use our understanding of graphs to help us identify the positive and negative sections. Very easy. All you have to do is look at your x squared. If it's positive, your parabola is facing up. If it's negative, your parabola is facing down. Well, this is positive. That means our parabola is facing up. So it's going to go like this. The vertex will be on the low side and go upward through those roots, the places where it equals 0. Okay, so that means this is above the x-axis. This over here is a positive section. This here is a negative section. It's below our x-axis. And this over here is above the x-axis. This is another positive section. So there's 2 positive sections and 1 negative section when your graph faces up. Just draw it through your roots. So now we've identified the sections of the answer set that generate positive or negative outcomes. This one wants the positive outcomes, and we can see that there are 2 of them. So when there are 2 positive outcomes like this, what we want to do is we want to write our inequality statement. So again, there was no equal to on the original, so we are not going to use equal to in our final answer. So this positive section starts at 1 and goes this direction, or greater than 1. So x greater than 1 is one set that will provide us with positive outcome. And we also have this direction. So we have x going this way, less than -7. So both of these are our set of values that satisfy the quadratic inequality. Okay, so the factoring part, you should already be getting, already mastery of factoring. Don't forget to move the right side over so that you have a 0 on the right. You use the zero product property to define for yourself the boundaries between the positives and negatives. You look to see which section is required by the inequality in the equation, and then you write your statement based on your graph. Use your positive x squared to face up, negative x squared to face down. So this is for the positives, okay? This is your answer set for the positives. If it had been flipped the other way, okay, so I'm just going to put in here, if this were a less than 0, meaning we're looking for the negative section, okay, less than 0 is negative section. The negative section is between these two numbers. So you would write it like this. -7 here means our x, or all the values, are between it. So we're going to have -7 is on the less side, like this. So x is less than 1, but at the same time greater than -7. Only if your solution is between numbers can you write it like this. Some students try to write this up here like this. Okay, and you look at it, x greater than 1, x less than -7. Unfortunately, you cannot write it like this. It's not the proper way to write this statement. The reason is this is an kind of like an or statement, meaning you can have this or you can have this. I put and in here. Technically, it should be or. And this is an and statement. When the two are together, it means it is less than 1 and at the same time greater than -7. This is an and statement. Means both have to be true at the same time. If you write it like this, you cannot be greater than 1 and less than -7 at the same time. It's actually an or statement. You're either greater than 1 or you're less than -7. So I see a lot of students trying to write this combined inequality like this. Please don't do that. It will be marked incorrect, and it is technically incorrect because of the difference between and or. So make sure only if your x is between the numbers, then you can write it as an one and statement. If it's going two different directions, you need to write them as separate statements, this or that. So please be careful of that. It's a simple mistake. Also pay attention to whether or not you include or don't include the equal sign. Okay, set up for just one more, just to make sure that you got it down. Okay, here we go. This will be our last example. Again, most of the skills you already have, you already know how to factor. It's just making sure that you interpret this correctly and kind of fine-tuning, especially that ending. We want to make sure that your ending is correct so that you don't lose unnecessary points when you generally have the right idea of what you're supposed to do. So here we see a quadratic, although it's not in order. We see a less than or equal to 3, and the instructions are going to say something like find the set of values. So again, that word set is a clue that you're dealing with an answer that has inequalities in it. And we see that this is a quadratic with inequalities. So the first thing that you want to do is put your quadratic in the proper descending exponential order. So this should be negative x squared plus 6x minus 5 less than or equal to 3. Notice the sign goes with the term. So the negative x squared plus 6x minus 5. So we now have it in the appropriate order. Another thing that we notice here is that we have a negative in the front. Now, you can leave the negative there, and if you did, at the end of the graph, at the end, when you graph your little graph to help you find your positives and negatives, it would face downward. But there is another way that you can do this without that negative. Sometimes factoring with the negative in the front gets a little mentally confusing. So what I would suggest is that you divide the negative through. So if we divide by -1, you get a positive x squared minus 6x plus 5, and you get a -3. Don't forget you have to multiply both sides of your inequality by -1. Now this is where you have to remember that when you divide by a negative, it flips your inequality. It will still remain with the equal component, but the inequality part will face the opposite direction. So you have a little give and take here. You either move the 3 over and factor it with that negative in front, or you divide the negative through and don't forget to flip the inequality. So either way, you're going to have to wrestle with something. Now, again, we can't use the zero product unless we have a 0. You could have subtracted 3 to the other side first. It doesn't, these two steps are interchangeable. So now we want to add 3 to both sides, and we get x squared minus 6x plus 8 greater than or equal to 0. So you can see that we could have subtracted 3 and got -8, and then divide by the -1, and you would end up with the positive 8. Okay, so these two steps can be done in either order. And again, you either deal with the negative and the factoring, or you divide by a -1 and flip your inequality. I like a positive x squared when I'm factoring. It just makes my mind more comfortable when I'm factoring. So the factors of 8 are 1 and 8, 2 and 4, and they have to add up to give us a -6. That means we're adding a -2 and a -4. Okay, we're adding to get a negative. So to add to get a negative, you have to add 2 negatives. So a -2 and a -4, meaning we have x minus 2, x minus 4 greater than or equal to 0. Let's just double check. X times x is x squared. -2 times -4 is positive 8. A -2x and a -4x is a -6x. So we're good to go. Again, we use our zero product principle to establish our boundary line here. So we get x minus 2 equals 0, x equals 2. We get x minus 4 equals 0, x equals 4. So our boundary line that we're looking at here has 2 and 4. Again, they need to be in the proper order. Smallest on the left, the larger on the right. Make sure you put them in numeric order on your number line. So these are the zeros, meaning graphically speaking, they're the roots. It's where a graph crosses the x-axis. Now, originally, we had been looking for the less than. Now, because we divided by a negative, it flips it around to being a greater than. So again, we see that we're looking for the positive section in the graph. And we also see that because we divided by negative, our x squared is now positive. So make sure that when you're drawing your graph in here, you're looking at your nearest work. Don't go back up here to the original because we've made an adjustment. So this here is what we're looking at. This is what we factored. So this is a positive x squared. So this graph should be going like this. You can see here's the positive section, here's the negative section because it's below the x-axis, above the x-axis, our positive section. This wants the positive section. So again, when we write our inequality, we want the positive, so x greater than 4. This is an or statement because we are going in opposite directions. Can't do both at the same time. Has to be one or the other. So this is x less than 2. And this is our answer set. Again, if we were looking for the negative section, then you could put x between 4 and 2 like this. If it were looking for the negative, we are looking for the positive set. So this is our answer. This is just if you were looking for the negative set. This is an and statement. You can be less than 4 and greater than 2 at the same time. This is an or statement. You're either greater than 4 or you're less than 2. These are the values, the set of values that will satisfy our inequality. If you just want to check, if you still haven't quite grasped the all of this positive and negative stuff, you can plug in a value, x greater than 4. Well, we can't take 4 because it doesn't have the equal. So let's take 5. If we put 5 back here in the original, we get 5 times 6. That's 30. Minus 5 squared. Well, that's 25. Minus 5. So we get 30 minus, 30. We end up with 0. Is 0 less than or equal to 3? Yes, it is. 0 is less than or equal to 3. You know what? I forgot to do something that I told you to do. I said make sure your answer follows the original. Our original has the equal, so I'm glad I checked over here because it reminded me we need the equals here. Whatever your original has, that is what you should have in your answer set. So we could have taken 4 if we wanted to. 4 times 6 is 24. Minus 4 squared is 16. Minus 5, that's 24 minus 21, which equals 3. So is 3 less than or equal to 3? Yes, 3 is equal to 3. So we can see that even using these endpoints of our section. Maybe you remember back in IGCSE material doing inequalities, but with one variable, not with 2 variables. So you would have drawn because of the equal, you would have drawn a solid dot and made your graph go that way. And you would have drawn a solid dot and making your graph go like that. And if it wasn't equal, you used the open dot, the hollow dot, the open dot instead of the solid dot. So maybe you remember that from IGCSE material. It's the same thing, but you're putting it into an algebraic statement as opposed to a graphic picture like that. Okay, so I hope this helps. It's very important. Make sure that you get this down. Make sure that you get your ending correct. A lot of students get the numbers right, but their inequalities are facing the wrong direction. And what I notice is they don't have any kind of visual aid to help them make the right choice. They just throw the inequality in and they end up losing a valuable point when this is a relatively easy concept. So, like I said, sometimes it will be a question type to itself, but most of the time it's going to be buried in another question type. And I think that we're going to see that when we get to part 7, when we have to use the discriminant or the z-squared, which is also the discriminant from the Potion method. Okay, so until next time, thank you for joining me, and I hope you enjoyed, and I hope that you can be successful on this question type.